All right, now that we've figured out this law of reflection, what is the law of reflection? It's that the angle from the normal line of the incident ray is the same as the angle from the normal line of the reflected ray, or the outgoing ray. You might see us write that as the angle. We usually use theta, Greek letter. The angle incident, I, that I stands for incident, equals the angle reflected, where that R stands for reflected. Okay. So the angle comes in at is the angle it comes out at. We might have said, oh, we knew that was the case, but we hopefully proved it experimentally. Right? So what am I going to do for this? I want to figure out where these laser pointers are going to hit. I'm going to apply this law of reflection. So this law, this physical rule, gives us predictive power. We don't have to do something to know what's going to happen because we now have this physical law. All right, so I'm going to say, okay, there's my incoming. I'm going to find where it's hitting the mirror right here. I'm going to use my protractor. Hopefully we're pretty comfortable at this point, drawing some normal rays, lining up that 90-degree line. Sorry, not normal rays, it's not a ray, normal lines. All right, okay, now close enough there. And I'm going to make sure I do the same angle on both sides. Now if I'm lucky, am I lucky? That laser pointer is going right along. This is a sort of a, if you're lucky and it goes along the line, you can say, oh, I'm 10, 20, 30, 40, 50 degrees one way. I'm just going to go 10, 20, 30, 40, 50 the other way. That's the way to do it. So that'll be where 10, 20, 30, 40, 50. I'm just going to mark a spot right there. And let me say, okay. It bounces off. It's going to bounce off right along that line. Oops, shifted my protractor. Whoops. Okay, and we hit that target. Let's double check just to be safe. Using our normal line. Here's my normal line. Here's my incident ray along here. And that's going to be 10, 20, 30, 40, 50 degrees. Make sure my other line, that's the bow, is the same. Let's go over here. 10, 20, 30, 40, 50 degrees. Great, let's just write that. 50 degrees, 50 degrees. That shows me, the person who would be grading your work, that you measured those and you know that they need to be the same. Okay, so that's our example for how to do one of these. We're going to look at doing a curved surface, just jog our memory on what we do in these situations. So first thing I'm going to have to do is I'm going to draw the laser. I'm going to line that up. I guess I started a little early, just needs to come out of the laser pointer. This first thing is knowing where does it hit the mirror, because I need to draw the normal line at the location it hits the mirror. For a mirror here, it's semicircular, which means our normal line is pointing towards or away from the center of the circle. So I'm going to line that up with my protractor. Draw that line going away from the center. Let's turn a light on here. It's better. Yeah. Okay. And I can use my protractor now to measure what that incident angle is. What is that angle between normal line and the incident light ray. Oh, these are light rays. We should be drawing arrows on them, just to make sure we're following the rules. All right. And that helps us distinguish things that are just lines and things that are light rays. So if we draw that arrow. All right, line her up. Oh, my protractor is upside down. Flip it over. That's looking like 50 degrees to me. Again, that's funny. The first example we did was 50 degrees. Our next step here is going to be to now measure that same angle for our angle of reflection. So I'm going to line up, get that center spot right where the ray's incident on the mirror. We need 50 degrees. So I'm starting from 0. I'm counting over to 50. I'm going to put a little dot there. All right. Ooh, are we going to hit something? Let's see. I'm just sort of tagging that there. Maybe I measured a little off, but looks like I'm able to, depending on how you measured, maybe even hit this one instead of that one. I'm not sure actually which one it's supposed to hit. Looks like my line was maybe a little high here, but as long as we showed this right idea, incident and reflected are the same. We drew the normal line correctly, we're good. Not going to worry too much about hitting that exactly. We can do this one that's inside the inside curve of the mirror. So imagine this is a mirror on both sides of this curved object. You've seen those in class. First I'm going to figure out where is the laser hitting the mirror. I'm going to use the center point to help me draw a normal line. I'm doing it on this side because I'm on the inside of the mirror. All right, might need to make that longer so I can measure something with my protractor here. Good. And I'm going to measure that with the protractor. I made this line long, so I'm going to use that to read the value. Line up my 0 here. And I'm going to count up. Looks like I'm pretty close to 30 degrees. I'm just going to call it 30. That looks pretty good. 30 degrees here. So I need to make sure that when I come out, I'm at 30 degrees again. So it's going to be one of these two targets. So I'll line up with my normal line this time, right at that spot where it's hitting. 30 degrees here. Mark that. All right, and this one we're definitely hitting that target dead on. Let's add our rays to this other one. I suspect I was supposed to hit this one on the previous example. All right, and there we go. I'm just going to do a couple more of these. I realize I've gone out of order, but I have to finish this anyway, so I might as well do it on camera. So, drawing the laser, it's hitting the mirror, lining this up, finding my normal line, perpendicular. I don't need to draw it on this side, I'm just kind of autopilot it. I drew this one long, so I'm going to use that to help me measure this angle between these two, the light ray and the normal line. I think this is supposed to be 40 degrees, but the way I drew it looks like I'm getting 39 degrees. 39 degrees. So So I'm going to go and measure that here. It's getting a little busy here with these other lines. 39 degrees is right there. Maybe you have 40. It's fine. No, this one definitely is supposed to hit here. I mean, I'm really suspecting that this line I did here probably was supposed to hit that other target. Yeah, what if we did that and then we did? Yeah, it's probably supposed to hit this one here. That's okay. As long as I'm showing I understand the idea of drawing the normal line and the reflected and incident rays are the same angle, I'm good. So if you're maybe struggling to measure to the exact correct degree, I would not fret about that. Now, if you're getting off by like 5 degrees, then that's something you really need to practice. But if you're getting within 1 degree of what I'm measuring here, not something to worry about if you're off by 1 degree or so. All right, I've drawn my incident ray. I've drawn my normal line. Let's give it a measure. Maybe we'll use this way. It's looking about 20 degrees. So we're going to try to draw 20 degrees for our reflected ray. Mark that 20. All right. Yeah, I think if we measure these all perfectly, we're kind of supposed to hit the center of these targets. 20 degrees here, 20 degrees there, 39 degrees here, 39 degrees there, 50 here, 50 there. All right, and I guess we just have one more. Have our curved mirror again, so we're just going to look at the center, draw our dashed normal line going straight away from the center of the circle at the location that the light is incident. Draw a couple arrows there, show our light direction. That's a small angle to measure, but let's do it. This one's not, oops, I'm off the camera. Hopefully I wasn't off the camera for other ones. I'm a little more than 10. Maybe if I did it perfectly, I'd be at 10. But we'll go with what I did. I'm seeing 10, 11, I'm getting maybe 12 degrees here. Maybe you did it better than me and you get 10. I'm assuming we're supposed to hit this guy. Let's see. So I'm going to do 12 degrees again. There's my 10, 11, 12. I guess can't. Struggles of left-handedness. 10 would be this longer line, 11, 12, put a little dot there. Draw our line, stop it there because I've hit the target. It's not actually going to go any further. All right, yeah, it's the only one. This was probably supposed to hit here, but the rest of these I feel good about. Let's make a little note. Probably should have hit this one if I measured better. next section. Here we're given the path the light is taking. Let's draw some arrows there to make this look better as a ray diagram. And our goal is to draw where the mirrors are. So one pattern we might notice looking at these is our normal ray. One word we could use is bisects or cuts in half the two rays here. So we can sort of use that idea to help us figure this out. Drop the protractor. Let's go in order, I guess. The light's hitting a mirror here. I want that line to perfectly bisect or cut these in half. So one way I could do this is I could measure the angle between them. This one's not a nice number, it looks like. I'm getting 10, 20, 1, 2, 3. Let's call it somewhere around 22-ish degrees. So half of 22 is going to be 11. 22 degrees divided by 2 equals 11 degrees. So I'm going to measure. I'm going to go 11 degrees here. And that's going to be my normal line. So I'm going to use my protractor as a straight edge. Draw that normal line. And now I can use that normal line to draw the surface. The surface will be perpendicular to the normal line. Draw a nice straight line there. Okay. So that's 11. That's 11. Important idea is I've shown that I'm following the law of reflection. The mirror has to be angled just like that in order for the law of reflection to be true. Okay. Ooh, what angle is this? It's an obtuse angle. I'm going from 0 all the way to, let's see. Maybe I'll go this way, because this line's longer here. We got 0 going along the top here, all the way to 125. It's not fun because that's an odd number. 125 degrees divided by 2, 62.5. You can use your calculator for this if you want. Again, we're off by a degree or so. I'm not going to worry about it. So I'm going to line up here. Here's my 0. I'm shooting for 62.5, so there's 50. Here's 60. 1, 2. 62.5 would be in between 62 and 63. So we're going to go there. Use that to draw our normal line. And that's going to let us draw a nice perpendicular mirror surface. Right, well, each of these is 62.5 and 62.5 degrees. Uno mas. You see, this is my longer line, so I'm going to use that to read the protractor. That one looks like a nice 60. No. Sorry, I need to divide it by 2 to figure out where this normal line is going to be. Or maybe you can maybe find other ways to do this, faster ways to do this, but this is a way that'll That'll always work for you. Oh, that should have been a dashed line. Oh no. Rough beats. Okay. Let's go. There's my mirror. Let's make a note. Should have been dashed. Very bold of me to do this in pen. And this is 30 degrees. This is 30 degrees. Oh, we're doing so well until that last one. Is what it is. All right, in the figure below, where does the red spot appear on the meter stick? So similar to what we've done before, with the hitting the target, we're going to draw a line that's hopefully going there. Usually, if this was like an assessment or something, I would start the laser pointer line for you, so you don't have to, you know exactly where it's going. Looks like, I don't know if I'm even getting it perfect here. Hit the mirror there. Draw our normal line, our perpendicular line. Make it nice along there so we can get it. Let me measure this angle. Line that up. I'm looking at, we're measuring from here, 10, 11, close to 15. Make sure I'm lined up well. Yeah, it looks like 15 to me. Right halfway between 10 and 20. 15 degrees. We'll throw another 15 degrees from the normal there would be, there's 10, there's 20, there's 15. You can sort of, actually did it right on the meter stick there, so I know where I'm going. All right. I realize it's upside down. Sorry to whoever's reading this solution maybe instead of watching this video. Okay. We're hitting somewhere, I don't know, if I had to guess, I'd say like 42. And that'd be 45 halfway. We're somewhere between 40 and 45, 42, 43 maybe. All right, around 42 or 43 centimeters. All right. Figure about what number on the meter stick would you see if you look through the paper tube. So if you're looking through the paper tube, you're not going to see all the numbers. If that wasn't there, you look in the mirror, you would see the whole meter stick. We're going to sort of backtrack here. We're going to say, okay, what light is able to enter your eyes from the paper tube? So almost the same as the laser pointer, except we're remembering that light goes into our eyes. These are so close to each other. There's my normal line. This line's nice, so I'm going to use that to figure out my angle of incident here. Looks like I'm right at 40 degrees, counting from the 0 up to 40. 40 degrees. So I'm going to go to my normal line. So we're measuring from the normal line, not from the surface itself. I'm going to count out, starting on this way, so starting with 0, 40 right here. Follow that up. All right, connect the dots. Okay, so there's some light source somewhere. We're just assuming at this point that we're not in a dark room. There's some light somewhere. It's hitting the meter stick, bouncing off the mirror, and going into our eyes there. Oops, this should have been the answer to this one. 42 or 43 centimeters. And this one, it's about, you'd see about 70 centimeters.